Hi there, my name is E.J. Daigle, the Dean of Robotics and Manufacturing here at Dunwoody College Technology. And this short lecture is going to go over an introduction to the mini-bot that we'll be using the second half of the curriculum here for the mechatronics course, and the MicroBasic Script, which is the programming language that we'll be using for this particular robot. All right, some basics on the robot itself. As you look at this robot, the chassis itself is a chassis that we order from a company called BotKits, all aluminum chassis, two-wheel drive chassis. So you'll see a wheel here and a wheel here. Those wheels are driven by 37 millimeter gear motors that are right here and here in the chassis. Each one of those motors is equipped with optical encoders, so we do get closed loop speed control for this robot. All of that control is done by Robotech's SDC2160 two-channel motor controller. So that motor controller is actually sitting right here inside the chassis. This little piece that's sticking up is just a little breakout board that we have mounted into the motor controller there. And then this hooks up to Robotech's MGS 1600 gyroscopic sensor. So this is actually a magnetic sensor that you see mounted on the front of the robot, and the robot is capable of following a magnetic strip that would be either placed or adhered to the floor of a factory, or embedded into the floor, or it could be embedded into concrete or anything like that. I've seen it installed underneath an epoxy floor coating, things like that as well. This is for all practical purposes, what we are building here is what's called an AGV, or an auto-guided vehicle. Auto-guided vehicle. That's what we're going to build. Now, because the coronavirus and other things going on right now, we're hoping to get back into the lab here soon and actually have you guys build these. But we'll start off introducing you to the MicroBasic programming language using a simulation software. So the exact same code that we will run on the hardware robot itself, we'll start in a simulated environment doing some programming. All right, so what you see on the right hand side here, first of all, is the MicroBasic script. Everything you see over here. It's just a snippet I took of some script that I was working on, working with the magnetic sensor itself. We need to install that software. We'll do a little overview of what that simulation software is capable of doing, go over the manual a little bit, and then we'll actually write our first program. So let's start off with the first step here, which is to install that software. All right, so I'll go ahead and discard my annotations there. What I want you to do first and foremost is go to the Robotech website. I think one of the beautiful things about having this on video is you can pause it, do what you need to do, and then catch up, rewind, whatever you need it is. But the Robotech website is roboteq.com, so robotech.com. When you get to that site, you're going to want to go to the support submenu there. That'll bring up a place where you can select the file downloads, or I guess it's files download. That's going to take you to a separate site. From this site, you can get all of the firmware, software for the various motor controllers, some of the software for the different sensors and firmware for the sensors, some of the utilities for the different things. If you scroll way down, actually all the way down to the bottom, it's not the very bottom, but a little bit up from the bottom, you're going to see a software package called RoboAGV Sim AGV Simulator. So this is an auto-guided vehicle simulator using the MicroBasic script. So what we're going to do is we're going to click on that. That's going to download the zip folder. You'll see the zip folder down in the bottom left of your screen here. You can go ahead and click on that zip folder. You'll go into that folder, and inside that folder you're going to see the setup RoboAGV Sim icon, little like unboxing software there. Why don't you go ahead and launch that and install the software. At this point, you might pause it and go through the installation process. Make sure that you acknowledge in the affirmative. If it asks you, do you want to allow the software to make changes? The answer should be yes. Do you want it to install it here? Do you want all the pieces? Yes, yes, yes. to all the things it's going to ask you. Once you're done installing that software, you're going to get an icon on the desktop of your computer. All right, I'll bring that up real quick here. So it's going to look like this. It's going to be RoboAGV Sim. That's the icon that we're looking for. Once you have that up and running, we can start to work with that. Let me just go back to my PowerPoint for a second. So first step, download and install the AGV software. So now that you've got that software installed, you can open it up. So let's go ahead and open that software up and just take a peek. What you're seeing right now is, I'll just give you a real quick kind of lay of the land here. There's a lot of pieces to this software. You're not going to be able to do some of the things that I'm going to do right now. We're going to build up to those. We're going to start off very basic and build up to those as time goes on. So to start off with, I'll just show you what this is capable of and why we care. First off, this is a simulated auto-guided vehicle. So if I went back to that PowerPoint and we looked at our AGV, it doesn't look identical to the simulation, meaning our sensor's in front and we're two-wheel drive. So maybe I want to go into the tree here, the configuration tree, and you can follow along if you want, I guess, at this point. Select the board. They don't have our 2160, but I will tell you the 2360 is almost identical. So I'll select the SBL 2360. When I go in there, I may want to make sure that I go under General, and we, instead of using separate motor control, we'll do a mixed mode. So we'll call it mixed mode 1. You can think of that kind of like, I don't know, like independently controlling the wheels or controlling them off of one command. So do I need to send a throttle command to each wheel independently, and then I'm going to steer by varying each one of those throttle commands, or do I want to send one standard throttle command and one steering command? So that's what mixed mode 1 will be for us. It'll be a little bit easier to control to start with, at least. And then under robo mechanical characteristics, you can change all these things. In the real world, you would want our wheel size to be correct, whatever the actual robot wheel size is, or the wheel base rather, the distance between the wheels. We also want to know what the wheel diameter is too. So the wheel base can help me with that turning radius and things like that. The wheel diameter is going to help me with things like speed, RPMs, such like that. You'll notice that this particular one has a front and a rear sensor. I'm going to change that front sensor to 250. And I'm going to change that rear sensor. I always think it's -1, and then usually if I hit enter, it's going to yell at me, and then change it to 0 anyways. But by doing that, I'm not going to have a rear sensor anymore. So I've got a 250 front sensor distance and a rear sensor distance of, I typed in -1, which gave me 0, and now what you'll see is you only have the one sensor. And this thing's a little bit more reminiscent of what our actual AGV looks like. Two-wheel drive with one sensor in the front. It doesn't have to be perfect, but it needs to be at least similar. So let me give you again a little bit of the lay of the land as to what this software does. First and foremost, just the overview here. What you'll see up at the top are a number of windows. So the first window is where you're going to open code. You can save code, you can bring code in, you can develop code right in here. The second one here is editing track. So if you go into that one, you can play with it for a second. Go into that. The red dot shows you where your robot is in space right now. And you've got a line, and if I was to draw a line from there to there, and then there to there, and there to there, and maybe back again, what I'd be doing is I'd be creating a track upon which that robot could follow around using a magnetic strip and a magnetic sensor. We're not quite ready to get that far yet. We will get there, I promise. But for right now, we're just going to erase that out. And I could also import that code. So I'm going to import some code. You guys won't be able to do this step, but I've got one with square corners here pre-built. I'll let that come in. You'll see it puts my robot right on the starting line of that guy. And I'm going to bring in some code that I've used in the past that I developed specifically for this one. I think it's called square corners. There it is. And you'll just see a chunk of code in here. Again, not critical that you are following along with the code at this point. More so you can see what I would be doing here. So in the real world, I've got an AGV, an auto-guided vehicle. Let's say it's a auto-guided, an autonomous forklift or an autonomous tug or an autonomous pallet jack. That when a pallet gets filled up coming off of this manufacturing line, it then needs to be transported to the shipping and receiving dock. And we're going to do that automated instead of relying on separate workers and separate machines. We'll have an automated line that does that. So in this particular case, if it was using just magnetic strips on the floor, when I hit run, what you're going to see is this vehicle is going to follow that line. If you don't believe me, what you'll see is it'll make a turn when it loses the line at the end here. It'll make a turn, start steering towards that other line. Oh, I can see right off the bat that I've got an issue there, right? So it should be finding that other line and navigating its way around there. I wonder if I've got the wrong code here. Let's try this. I might even just try a different value in here. I know where that's at here. Right down here. So maybe instead of 22, I'll do 26 and see if that makes an effect on this. So I'm just doing a little live debugging, but you can see how I might utilize this. I might say, well, I want to get down to the end here and I want to make a turn and try to acquire that other strip. So I'll make a little bit of a turn. Hopefully I didn't quite acquire that other strip, right? So you can see what we're going to do with this as we're playing with it over and over again, trying to get it to do different things. I'll hit 35, hit save, and hit play again, and see what it does this time as it's going to navigate around. See if it gets a little further. Hoping it turns a little further this time. Not really. Getting the same message there. Let's go back into the code here. So if tape detect true, then do this. Else, we're going to go into here and make this turn. I'll up it a ton and see what happens here. Save, save. And one more play. If this doesn't work, that's okay. Oh, we definitely got a bigger turn there, didn't we? Now you see I've required that line and I'm going at the other side there, and I have no idea if I'm going to require any of these lines, so don't pay too much attention, but you can kind of start to see my thought process as I'm building this code. I would tell you it'd be a little better to go at that distance until you acquire the line instead of trying to pick it up at an angle like this particular chunk of code was working on. So anyways, but that's the whole goal, is just to kind of show you. I can always reset my model if I want to play it again and start from the beginning. I just hit reset and go on. So this is the type of stuff we'll be able to do with this AGV simulator and the AGV technology, and then the physical mini-bot itself that we'll be able to explore. All right, so that's not the code I want to write right now, though. What I want to do is I want to start off with some new code. So I'm going to go to new, and this is where I think, let me just see where we're at in our PowerPoint here. So we've downloaded, installed, we've given you a basic overview of the software. Oh, here's what I want to do. I want to get everybody a copy of the MicroBasic Scripting manual too. I found the easiest way to do that, actually, to find the MicroBasic Scripting manual, is actually just to bounce out of here, go to Google, and instead of doing it in Robotech, just type in MicroBasic Scripting. I see I've typed it in there before, manual. As soon as you do that, the first thing on the list under MicroBasic Scripting manual is going to be the MicroBasic Scripting manual. I highly recommend opening that up and downloading this document, the MicroBasic Scripting manual. I keep it in a folder on my computer that I call it Mini-Bot Fun, but you could put it in your mechatronics folder, and you'll want to download that MicroBasic Scripting manual and put it in there. The reason why is, let's say as an example, you're trying to figure out how to use a for next loop. So I might go into the scripting manual and just type in the word next. Do a quick Control F for the word next. And I can see the for next statement is on page 22. So I'm going to go down to page 22. And I think I know how the for next loop works, but I'm not positive. So I'm going to drill into the documentation here. And I can see the for next statement on page 22 here. And it gives me both a traditional model of the for next loop, which it says it is not recommended, but then it gives what's called the C style. I didn't know there was a traditional style and a C style. I just knew for next loop is all I did. In this particular case, it tells me what to do. It says, okay, for some variable equal to something, and so I could say, an integer equal to 0, and while that integer is less than 50, let's say, I want to execute this chunk of code, right? And then when I get to the end of that, I'm going to go to next. And what that's going to allow me to do is that's going to allow me to loop back around to the for, and I'll loop that for 10 times, 20 times, 30 times, whatever I want to do. So let's actually do that then. So now that we've got all the pieces, we've got the software, we've got a very, very brief understanding of what the software does, and we've got a copy of the scripting manual so we can start writing some script and looking up on the manual how to do it. There are a couple other things we'll get at a later time. The STC 2160, that's the motor controller data sheet, but for the simulation we don't need it. And the MGS 1600 data sheet for the mag sensor. Again, for this first simulation, we won't need either one of these, so don't worry about downloading these right now. So let's write our first MicroBasic program. So let's go back into the AGV simulator software, and I'm going to I'm going to go to the eraser tool here, and I'm going to get rid of my lines here on my track. So just know I went in to edit the track, and I could either put tracks in like this, or I could grab the eraser and erase those tracks out. So right now I'm just removing all of them. And for that matter, I'm not even going to use the AGV at all for this very first kind of almost like a hello world chunk of code that we're going to write. What I'm going to do is I'm going to go into my open code, and you may want to hit new code. So I'll hit new, and we'll walk through what I would consider the most basic program we could possibly write. All of our programs that we're going to write are going to start off with option explicit. That's what we're going to type in there, option explicit. All right. What that means is in our program, we're going to explicitly define our variables. We're going to name them the way we want and tell them what data type that we're going to use. This is a very common first line in any basic programming language. And then what we're going to do is we're going to go ahead and define one of those. We're going to say DIM, which stands for define in memory. We're define, let's do an integer, int1 as integer. Okay, so we define int1 as integer, and we're going to define in memory bool1 as boolean. Well, that makes sense, right? I defined an integer, I defined a boolean. And if you ever want to put comments in here, I just kind of scroll to the right, I put in a single quotation, not the double quote, and I say that there are two types of data. Integers, oops, I should be able to spell integers though, right? Integers and booleans, or bools. Those are the only two types of data available to you in MicroBasic. So if you need to do a floating point number, that's going to cause you a little bit of grief. I've seen people do things like multiply by 1,000 to turn it into an integer, and then divide that 1,000 at the end, realizing decimal portions are going to get truncated as part of that multiplication and division. But it can get you very, very close. For our particular purpose, especially when we're talking about our AGV technology, we can make it work with just integers and booleans. That is very much sufficient. Now we'll do that for next loop. I'm going to say for. We've defined integer 1 as int1. For int1 equal to 0, so we're going to give it a starting value. Int1 is generically set to 0 when you first launch code anyways, but we're going to explicitly define it, and we're going to explicitly set the first value into it, which will be 0. And while, I will tell you it's very common in programming to start a statement off with a lowercase, and when I want to separate two things or two words, and while we'll have an uppercase W. So and while int1 is less than 25, so for integer 1 equal to 0, and while that integer is less than 25, I'm going to do a chunk of code. And I'm going to do dumb things with this code. I'm going to say wait 100, which I'll put a comment over here so we know what that means. It means wait 100 milliseconds. So that's what the wait function does, the number of milliseconds. You don't have to have a space in there. I don't think it hurts anything. And then we're going to print int1. So this is the silliest, it's kind of like a hello world. This does almost nothing. I'll put a couple spaces in here so we can look at it. Normally I wouldn't have spaces in here, but for the purpose of us kind of separating what's happening out, I'm going to print to the consoles. What this is actually going to print to the console. I'll mention that, print to console, the value of int1, and then we're going to define next. And what next is going to do is going to take me back up to my for loops. So as I start out at int1 equals 0, I wait 100 milliseconds, I print out that 0. The next tool does two things. It's going to increment the count in int1, and it's going to bring me back up here. So this is going to be it's essentially what's going to cause me to loop. Causes loop and increments int1. It's worth noting, when you're writing code, you're not going to need to put these comments in. I'm only doing that because this is our first chunk of code and we've never done this. So let's see if it works. Let's hit build. So I hit build, I get no errors, no warnings. That's a good sign. I can then X out of that and I can run my code. Now it's worth noting my AGV is not doing anything because we haven't told the AGV to do anything. When I run it though, look what it does down here. It actually counts. If I hit recycle or reset, it counts from 0 up to 24. Now that may be a little bit hard to see because it's kind of clustering all those numbers together. But when you do it, you can actually see it counting from 0 to 24. It might be easier if we were somehow able to put that on a new line. And guess what? We can do that. So where it says print int1, I'm going to put a comma, space, quote, /n, quote. And what that's going to allow me to do is that's going to allow me to put that onto a new line. So I'll hit build. No errors, no warnings. I'll hit run. And now it goes vertically from 0 to 24. And you might say, well, I thought we said it was going to go to 25. Well, it did. Remember, it started at 0 and it did it as long as I was less than 25. Well, 24 is less than 25. So I wanted to go 26 or 25. I might say less than 26. Now we go less than 26. I don't need to save it. I can just go into it. Now it's going to go down to 25. Or I could do less than or equal to, or something like that. So that is the most basic of basic things I can show you in MicroBasic. So for this first lesson, prior to starting your what I would call your homework or us even getting into our main part of the lecture series here, for this first video, please go down, download the software, get it installed, and make sure that you can at least write this very trivial chunk of code here so that you can make it work. And then once you have that going, you will be ready to go on to the second video lesson where we'll actually do something a little bit more interesting and talk quite a bit more about the MicroBasic Script. Let me look at my notes here. We'll get into some of the details as to how the language works, how it compares to some of the traditional programming languages, the data types and the limitations of the data types, timers, waits, the different conditional statements, looping statements, and continue to write some more code as well. So with that, I'm going to go ahead and stop this video. And please feel free to get a hold of me if you have any questions or any trouble downloading or installing the software. Thanks.